Number 6, we have log of 14 over 4. And if you write down the correct answer with no work here, I'm not going to give you any credit because I told you in the directions to use 2 facts. We can use our properties of logs. If things are being divided, how do we break it apart? So this is the log of 14 minus the log of 4. Okay, then when I look back, the log of 14 is 1.146. I gave you that decimal. Minus the log of 4, 0.602. So if we subtract those, we get 0.544. So I'm expecting you to show me this step so that I know you understand the property and you applied it. So problem 7, we have the log of 56, and all I know is log of 14 and log of 4. So how am I going to use that? Fourteen times 4 is 56. So properties of log says that's the log of 14 plus the log of 4. So I need to see this step to know that you understand the property. Then we put in their decimals and add that together and we get 1.740. Number 8, I have to rewrite 16. 2 different options. What could we do? Okay. The other option is to write it as, right, 4 times 4 where you would add logs. If you do this, properties of logs, that comes down. So you could either have 2 times the log of 4 or log 4 plus log 4, depending on which one you did. So 2 times the 0.602 gives me 1.20. Is that one okay? Problem number 9. First, we need to isolate the exponential. So we have to subtract our 7 over it. Then we always check, is it possible to get a common base? No. A disclaimer, if from here you go to log base 8 of 20 equals W, have I taught you how to evaluate this? No. Some calculators have that option, some don't. I am not giving you any credit if you do it that way. Okay, you have to use the properties that everybody has access to. So what we've talked about in class. What did we do on these problems in class? We add a log to each side. And the benefit of that is now the properties of logs, the W comes down in front. So it's W times log of 8, so we can divide log 20 divided by log 8, and that everybody can put in the calculator because we all have that log button. When you type that in, make sure when you push the log, it opens the parentheses, so you have to close it, and you should get 1.406. Questions there? Okay, so are we okay with 10 through 13? Didn't ask about any of those. Problem number 14. We have 3 to the x squared plus 1/2 x equals the square root of 3. So we have options. You could go through and add a log here, but probably more helpful is to realize a square root is the same thing as what? 1/2. So you can set the exponents equal to one another. We have x squared plus 1/2 x equals 1/2. Alright, probably the thing that confused you here was the fractions. So I saw some people went into quadratic formula, which is fine, you'll get the right answer. Another option is to eliminate the fractions. If that's what's making it hard, how can I get rid of it? We get 2x squared plus x equals 1. Or if you set it equal to 0, 2x squared plus x minus 1 equals 0. Now we could do slip and slide. What multiplies to -2 and adds to +1?
2.
So then we come back and divide them by 2. So if those equal to 0. We get -1 and +1/2. On these, we can always check it just by plugging it back into the original. Any questions on that? When are the problems that you get answers that don't always work? Remember which ones those are? Right. If the original problem starts with a log, that's when you definitely have to check because your answers may not work out. The exponential ones, our answers should work as long as we didn't make a mistake along the way. Problem 16. We've seen a few of these so far. You will have one on your test. The key to this is having your work neat enough that you can read it. It's kind of the biggest issue I've seen. Is it possible to get a common base? No. So we add a log to each side. The benefit of that, when you add a log, what happens to your exponent? When you bring that in the front, you have to put it in parentheses. Log of 7 and this x minus 2 comes down. Log 5 is just a number, so we can distribute that. When you do, the x is just going in front of my log. So this is x log 5 plus 2 log 5. Over here, x log 7 minus 2 log 7. How does this help me? Everything with an x on one side and everything without it on the other. Now, when I bring this over, they aren't actually like terms. I can't subtract them. I'm just rearranging things. So the way I set mine up, I would have x log 5 minus x log 7 equals 2 log 7 minus 2 log 5. Then what? Greatest common factor. They both have an x. So at this point it is x times something. You get x by itself, you divide. Make sure you write that statement. Some of you are having trouble putting it in the calculator. If you have your answer written, then you'll get credit for that. You'd only miss that final point for the decimal equivalent. But if you don't write this down, I don't know what you're putting in the calculator. Okay?
Could you simplify that top one to make it to both -2?
You could factor out a -2 and make it out the -2. Then it would be log 7 plus log 5. And you could write it like that. when you're putting these in, we've talked about different options, so the nice thing on the test, you will have the non-graphing calculators. And so these have a nice, easy to access fraction button on them, the N over D. I strongly recommend using that so you can see it set up in fraction form and make sure you have everything correct. Otherwise, you have a lot of parentheses to worry about. Every time you open a log, you have to close that parenthesis. And if you're not using the fraction button, you have to put a second set of parentheses around both the top and the bottom, so it gets a little cumbersome. But this should come out to be 21.133. If anybody needs me to look at how they're typing it in the calculator, if you're not getting the right answer, let me know. Any questions there? Problem 17. Can I multiply the 2 and the 8? No. Order of operations says you have to do exponents before you multiply. So I'm going to change my 8 to 2 to the 3rd. How can I rewrite 4? So we have 2 to the x plus 1 times 2 to the negative 3x plus 2 squared. If you are multiplying these 2's, what do you do with the exponent? And the base doesn't change, so it's still a 2. X plus 1 plus negative 3x. Now we have a common base. Base 2 on each side, so you drop the base and set the exponents equal. So negative 2x plus 1 divide, and x is negative 1/2. Number 18. So now we're getting into some problems with logs, which means we have to do what at the end? Check our answer. What are we checking for when we check our answers? Argument has to be positive. So we have log of x plus 3 plus the log of x plus 4 equals 1. So first we need to condense. If 2 logs are added, how do you put them together? Multiplication. We are multiplying these arguments. So x plus 4 times x plus 3. So if we FOIL, that's x squared 7x plus 12. Okay, if it's a log on both sides, we just drop it. If it's only on one, what do we have to do? What's the base of this log? Remember, these are like the first 4 questions going back and forth between the 2 forms. This is 10 to the first equals x squared plus 7x plus 12. Subtract over the 10. Oh, yeah. So we try to factor. Does anything multiply by 2 and add 7? No. So if we can't factor, what do we do? All right, you should know this. Opposite of b
Plus or minus square root of b squared minus 4ac.
Oops. Okay. So, -7 plus or minus the square root. 49 minus 8 is 41 over 2. Okay, this answer is all well and good, but what do I have to make sure? Right, has to work. So you are verifying when you put this in and add 3 and add 4, you're getting positive numbers. If you want, you can leave this in radical form, or you can turn it into decimal. So if you do the -7 minus radical 41 over 2, that gives us a -6.7016. If you do -7 plus radical 41 divided by 2, that's a -0.2984. So when I look, can we put in a -6? No, because that would give us a negative. But the -0.29 is fine. So it's this answer, or if you put -7 plus the square root of 41 over 2, you can't have the -1, but the +1 does. So I'll take either answer there. All right. Are those okay? Let's look at problem 19. So this one has a lot of logs in it. Log of x plus the log of x minus 2 equals the log of x plus 4. And there's really two different options. We can move everything onto one side and put it together, but the easier option is probably just to work to get one log on each side. These logs are added, so what do we do with the arguments? So that would be x squared minus 2x. Then, what do we do? Since there's one log on each side, we can drop that. So if I subtract over my x, subtract my 4, what multiplies to -4 and adds to -3? Okay, so it goes to 0 and x is, and then check. If we put in a 4, 4 is good, 4 minus 2 is good, 4 plus 4 is good. But -1 is not. So 4 is my only answer. So problem 20 is going to be very similar. Because if we look, we have 4 terms. Every one of them has a log on it. Natural log x minus 1 minus natural log x plus 6 equals natural log x minus 2 minus natural log x plus 3. If logs are subtracted, how do we condense them? So on each side we get a division problem. Now I have one log on each side, which means is this helping you guys to go through it? What would we do now? So if I FOIL those, we get x squared plus 2x minus 3. FOIL these, so x squared plus 4x minus 12. Lucky for us, when we subtract the x squared, what happens? Okay, I can bring over my 4x, add over my 3, divide, and we get 9/2. So that's like 4.5. So 4.5 minus 1 plus 6 minus 2 plus 3, all of those are good. If one of them wasn't, what would my answer become? 21. All right. On these, I will give you the formula, but you have to know which one to use. When do we use the formula with an E? Continue. continuous interest. Did I say continuous anywhere in this problem? No. So we are using the other one. A equals P1 plus R over N to the NT. So we need to figure out what all of our variables are. Okay, let's go through the problem and look at our numbers, figure out where to put them. Find the present value. So that's the thing I don't know. What variable is present value? P. Present value is P, sometimes called principal. It's your starting amount. Of $15,000. So what does the 15,000 represent? A. That's what we want to end with. At 2.34%, your percent is always your R, but you have to move the decimal back 2 places. So 0.0234. Compounded monthly, what's that? N is how many times a year you would compound. So monthly would be 12 total times. And T is time in years. So if I say 42 months, how would I change that into years? So make sure you know. R always has to be a decimal. T is always in years. So now we plug in. A, 15,000. Well, P, we don't know. 1 plus 0.0234 over N to the N times T power. All right. My suggestion to you is you can evaluate all of this. You're going to have some decimals. We could just get P by dividing that whole thing over and type everything into our calculator at once, which might just be the easiest option. Otherwise, just make sure you're leaving a few decimal places when you work that original part out, because it doesn't work nicely. So I have 15,000 divided by all of that. P is a dollar amount, so you want to round 2 decimal places. So we have $13,821.56. So please, if you're doing that, it's helpful to make a list of your variables and see what you have so you know where to plug it in. Okay? 22. Okay, trying to decide if something is 1-to-1. We talked about several different options for doing this, but I think the best for us is just to think about a graph, because we graphed these. We did a lot of graphing on our last test, right? And this is just a rough sketch for you, so it does not have to be perfect. What is my parent function? X squared is a parabola. Okay, how is this parabola going to move? Left 1, down 6. What's the 2? This does not have to be very accurate to get us our answer. So we're going left, we're going down. We know the 2 is just going to make it skinnier, right? That's really enough for what we're looking at. I don't need exact points. If it is 1-to-1, 1-to-1 means, yes, function is vertical line test. 1-to-1 is horizontal line test, which says if you can draw a horizontal line that hits this graph more than once, it's not 1-to-1. And we can draw a lot of them, right? Are parabolas ever 1-to-1? No. So this fails the horizontal line test. So it is not 1-to-1. We had to have 1-to-1 functions when we were finding inverses, because if you find the inverse, it flips x and y. If the original isn't 1 to 1, what happens when you find the inverse? So in this, it's saying y gets repeated. If you try to do an inverse, that means x would be repeated, so it wouldn't be a function. So we'd say it fails for a Klein test. What does that mean? There is no inverse. The inverse would turn out to not be a function, so we can't do it. So then we got into finding inverses. On the last quiz, this was the thing a couple of you had kind of forgotten what to do, so make sure you remember. So our function. First step, you have to change your f of x to a y. Okay, so y equals 1 over x plus 2. Step 2, you switch x and y. So x equals 1 over y plus 2. Did you guys get this far? Step 3, we're trying to turn it back into function notation. So you have to solve for y. How would you do that? So we get xy plus 2x equals 1. Xy is 1 minus 2x. Divide by x, so y is 1 minus 2x. And then step 4, change y to f inverse of x. We'll write it as f inverse of x equals 1 minus 2x over x. Remember, the domain of the original, the x's in the original become the y's in your inverse, so those are the same. If I look back at my original, if I have a fraction, what has to be true? So I know x plus 2 can't be 0. So x can't be negative 2. So that means negative infinity to negative 2 union negative 2 to infinity. The range of the original, the y's to start with, become the x's in the inverse. If I look at my inverse, what's true about my domain? Denominator can't be 0. So it's negative infinity to 0. Union 0 to infinity. So make sure you can give me the domains and ranges when you get to the end. And you have to label what's what. Domain of the function, range of the inverse, and so forth. Yes?
Can you check mine?
Sure. Oh, that's a good question. Yes. What you did is you, yeah. Yes, you might have had this written differently if instead of distributing your x, you divided it. So if you had 1 over x minus 2, that is also equivalent. 24. All right, so step 1, instead of f of x, we write a y. Step 2, we switch x and y. So the y becomes the x, both x's turn into y's. What would we have to do next? Try and get rid of fractions, so multiply over the y minus 1. Okay, I'm trying to solve for y, so we need the y's on the same side. So I'm going to subtract over this y itself, we divide, so that's 2 plus x over x minus 1. So final step, the inverse, 2 plus x or x plus 2. X minus 1. Domain of the function is the same as the range of the inverse. If you look back at the original, bottom can't be 0, so x can't be range of your function is the domain of the inverse. If I look at my original, my denominator is the same, so x can't be 1. This function actually turned out to be its own inverse. Doesn't happen very often, but it's possible. All right, is that one okay? The domain. You have two options. We're reviewing for test. You can come in and tell me something. I can get you in a second. When we're finding the domain, we could draw a graph and look at a graph, but it's easier. We've done all these log problems, and every time you solve one of the equations with logs, at the end I tell you to check your answer. What are you checking for? When you plug it in, it has to be positive. So this argument, the 2x plus 3, has to be a positive number, which means it has to be greater than 0. And then that's a pretty easy inequality to solve. 2x is greater than negative 3, so x is greater than negative 3 halves.
Wouldn't x equal 3 halves, or negative 3 halves be your asymptote?
Yes. So then our domain, if you think about what it's saying, x is greater than that, so it's everything larger. So you would tell me negative 3 halves to infinity. Or you could draw the graph and get it from there as well. All right, are there any other questions on the study guide that we haven't hit? Is there anything in general you want me to throw a problem up? First thing I would start with are these coefficients. What can you do with the coefficients? So this 3 makes it an x minus 1 cubed. Minus. Take out that 4. So x plus 3 to the 4th. Okay, if I take away this 5, that's y to the 5th. So now I'm putting these as one big log. If it has a positive in front, it's going on top. So x minus 1 cubed goes on top. This one is minus. If it's being subtracted, it goes to the This one is also subtracted, so it goes on the bottom. Several people asked me if it was okay. They had times x. I put the x in front. It doesn't matter as long as we have x on the bottom. And what about this y? Where would it go? Top. It's adding. Anything that's positive is on the top. So you could give me your answer like that. Anything else for the last 5 minutes? Make sure